She has 7 dots. The red one brings good luck. She's drawn on children's notebooks, mugs, and postcards. Every child knows her name. A symbol of summer, a symbol of the garden, a symbol of something kind and small. But that's about another one. The one we're talking about today, the yellow one, with 22 dots. She doesn't eat aphids at all, ever. She eats what other insects don't even consider food. And she didn't get to your garden beds by accident. She went there deliberately because you yourselves created the perfect conditions for her. Today, the 22-spot ladybird. Who is she? Where did she come from in Russia? What is she doing to your garden? And why fight her? It's not what you think. Stay until the end. Let's start with what everyone knows wrong. The word ladybird in the name is neither accidental nor unkind. In most European languages, these beetles are called cows. Ladybird in English literally means the bird of the Virgin Mary. In German, it's called Marienkäfer, the Mary beetle. In French, it's called Beth Abomde, the little animal of the good God. In all cultures, there's something sacred, something under heaven's protection. Why? Because in medieval Europe, aphids were destroying the harvest, and suddenly a small red beetle would fly in and start eating them. The peasants didn't know entomology. They only knew one thing: they prayed, and help came. The ladybug family isn't just a dozen species, it's more than 6,000. 6,000 species across the planet, in different sizes, different colors, with different numbers of spots. There are 2-spotted ones, 10-spotted ones, 14-spotted ones. There are ladybugs without any spots at all, just solid-colored, as if someone forgot to add them. There are black ones with red spots. That is, the color scheme is mirror image. Dots are not decorations. They are a warning. Any bright color in nature means one thing: don't eat me, you'll regret it. Ladybugs secrete a bitter orange fluid, hemolymph, from the joints of their legs. It tastes disgusting. A bird will taste it once and remember the color forever. Therefore, red and black serve as a symbol understood without words on all continents. Our heroine is the 22-spot ladybug, Silabora vintidopunctata. Yellow with black spots, small, about 3-4 millimeters in length. For comparison, a typical 7-spot ladybug is 7-8 millimeters, meaning ours is almost half the size. But it's still strikingly noticeable because yellow and black are a combination nature uses as an alarm signal no less often than red. 22 spots. It's for these spots that she got her name. 11 on each elytron, for a total of 22, and 5 more are hidden on the yellow forepart. So there are even more spots on her than her name suggests. They are arranged strictly symmetrically, as if drawn along a ruler. And here's where the main thing begins. Almost all ladybugs are predators. They eat aphids, mites, whiteflies, and small caterpillars. This makes them valuable allies for any gardener. This is precisely why humanity has fallen in love with them. But the 22-spot ladybird is a complete and utter exception. It has never eaten a single aphid in its life. It eats powdery mildew. Not insects, not eggs, not larvae. Fungus. A microscopic fungus that covers leaves with a white coating, the same one that makes gardeners despair. Powdery mildew on cucumbers, pumpkins, zucchini, phlox, gooseberries. A white powdery coating that appears in late summer and can destroy an entire bush in a few weeks. The 22-spot ladybird specializes in precisely this. Narrow specialization is rare even among insects. Most eat whatever comes their way. That's just powdery mildew. Larvae, adult beetles, they all eat the same thing their entire lives. Now think about it. Powdery mildew is one of the most common garden fungi in the world. It's found wherever there's moisture and warmth. And it has a natural enemy that eats it with relish. Yet people barely notice a ladybug, which looks like a toy, and yet functions as a biological fungicide without chemicals or sprayers, simply lives and eats. But here's the paradox. This particular ladybug was long considered a pest in Russia. Problem is that it doesn't clean off powdery mildew perfectly. After its meal, characteristic marks remain on the leaves eaten out patches of white coating mixed with untouched ones. Gardeners have seen a yellow beetle on a diseased leaf and drawn the logical conclusion: the beetle is ruining the plant. The logic is clear, but it's exactly the opposite. The beetle doesn't ruin the leaf. The beetle heals it, slowly, methodically, square millimeter by square millimeter. But what is powdery mildew, anyway? Because without it, the scale of the disease is incomprehensible. Powdery mildew isn't a single fungus, but a whole order of erysipelas fungi, with about 900 species, and each specializes in its own host plants. One species attacks cucumbers, another gooseberries, a third roses, a fourth cereals. They are not interchangeable. The fungus from your cucumber won't jump to your rose. It doesn't have the necessary tools for that host. Its narrow specialization mirrors that of the ladybug. The white coating on the leaf is mycelium, the fungal threads that spread directly across the leaf surface, not inside it. This is important. Most pathogenic fungi penetrate the plant. Powdery mildew lives on the outside, literally on the surface of epidermal cells. It inserts specialized feeding organs called hosteria into the cells and sucks out the contents through them. The leaf looks flower-dusted on the outside, but the cells inside are slowly dying. A fungus with pores is spreading. And here's the detail that makes me uneasy. Powdery mildew spores are carried by the wind over vast distances. There are countless of them, and they're in the air in your garden right now, in the summer, any day. The only question is whether they'll find the right conditions for germination. The conditions are simple: warmth and slightly elevated humidity. No rain, no puddles, just humidity. Therefore, powdery mildew is especially active in late summer, when the nights become cooler and more humid, but the days are still warm. An ideal incubator. In an unfavorable season, powdery mildew can destroy a significant portion of the cucumber crop, up to a third or more. It doesn't spoil, it destroys. In Russian vegetable growing, this amounts to billions of rubles annually. And against this enemy, nature has a small yellow beetle which we unknowingly crush. Now let's talk about its internal structure, because the biology of this beetle is a whole other story. The 22-spotted ladybird lives for 1 year, or more precisely 1 full cycle. Into spring, when the temperature consistently rises above 10 degrees Celsius, the overwintered adult beetles emerge from their hiding places. They overwinter in litter under bark, in cracks and fences, in dry places away from direct frost. Not in groups like some other ladybird species, but individually or in small flocks. The first weeks after emergence are a recovery period. The beetle feeds, accumulates resources, and then mates. The female lays eggs directly on leaves affected by powdery mildew. It's no coincidence that they are close by, right where food is already available. This is a precise calculation. The hatched larvae should not go anywhere for their first meal. The eggs are small, yellow, oval. They are easy to miss. They are less than 1 millimeter in size. The larvae hatch in a week or a week and a half. They look nothing like the adult beetle. Grayish yellow, elongated, with dark, warty growths on the sides. They look strange. Most people who see them for the first time mistake them for some unknown pest and crush them. This is a mistake. The larva of the 22-spotted ladybird feeds on the same powdery mildew as the adult beetle and eats actively, perhaps even more actively. It goes through 4 stages of development, or what entomologists call 4 instars. Each time it molts and grows larger. The entire larval period lasts about 3 weeks. Then the pupa opens, right on the leaf without a cocoon. Yellow, motionless, attached to the surface. After a week or 2, a young beetle emerges. At first it is pale, but the opening has not yet hardened and the spots have not yet appeared. Within a few hours, the coloring deepens, the chitin hardens, and before you is a fully developed and 22-spotted ladybird. 1 or 2 generations can occur over the summer. It depends on the climate and summer temperature. But here's a question I couldn't get out of my head for a long time. A garden has hundreds, sometimes thousands of leaves. Some are affected by powdery mildew, others are not. How does the beetle find the right leaf? Does it examine each one? No, it has a nose, or rather a chemical detection system that works through antennae. Powdery mildew, when actively developing, releases volatile organic compounds into the air. These are a byproduct of its metabolism. The fungus doesn't hide. It simply lives and releases them. For the plant, these substances are a distress signal. For the ladybird, they are the scent of food. The beetle detects these compounds with its antennae from a distance, flies towards the scent, and lands on the affected leaf. This is not chance or luck. It is precise chemical navigation honed over millions of years of evolution. The same mechanism operates when choosing a nesting site. The female doesn't simply lay her eggs where she sits. By smell, it locates the leaf with the most active fungus, where the plaque is heaviest. The more severe the infestation, the more attractive the leaf. The 22-spotted ladybird is no exception in the insect world. It's part of an entire evolutionary lineage. The ladybird family includes a separate tribe, the Halidcini. Several dozen species are found across the planet. All are exclusively fungus eaters. All specialize in powdery mildew or related fungal pathogens. Different continents, different climates, different host plant species, but the same feeding strategy. This means one thing. The transition to feeding on fungi turned out to be so advantageous that nature independently invented it several times, or even once, and this trend proved promising enough to give rise to dozens of species. Among predatory ladybirds, there is fierce competition for aphids. Among mycetophages, there is a virtually empty niche. While everyone else was fighting for one thing, these ladybirds chose another, and won. Now the main question, where did it even come from in Russia? The 22-spotted ladybird is a native European species. Its historical range encompassed Western Central Europe, the Mediterranean, and part of Asia Minor. It has always been present in Russia, but only in the European part, roughly up to the Urals, and was perceived as a background inconspicuous species, neither a pest nor a helper, just there and there. But in recent decades, the picture has changed. The beetle began expanding its range east and north to places it hadn't been before. Western Siberia, the southern Urals, areas where it had never been recorded before. Entomologists are recording new locations every season. Why? The answer is simple and inconvenient. Climate. The average temperature of the growing season in Western Siberia has increased slightly over the past 30 years, but for an insect with a one-year cycle, even half a degree matters. Winters have become milder, springs are coming earlier. The beetle, which requires stable temperatures above 10 degrees Celsius to be active, has simply received more such days and, at the same time, more food. Because powdery mildew also loves warmth and humidity. The warmer the summer, the more active the fungus. The more active the fungus, the better the food supply for the ladybug. A perfect circle. Another factor was at work at the same time, the gardening boom. In the 1990s and 2000s, the number of private plots with cucumbers, zucchini, pumpkins, and ornamental plants increased dramatically. All of these are ideal hosts for powdery mildew. Without realizing it, humans created a network of feeding stations for the beetle across the country. Have you ever noticed a small yellow beetle with spots on your cucumber leaves? Let me know in the comments. I'm really curious, from which regions are the respondents? Since we're talking about Russia, let's dwell for a second on the word itself. Korovka. Why a cow? There are several theories, and none has been definitively proven. The first comes from the word blood. In Old Slavonic, korov and blood shared the same root. The beetle, which secretes a red fluid from its leg joints when in danger, could well have gotten its name for this very reason. Blood beetle, ladybug. Second version, through imagery. In peasant culture, the cow was a symbol of a nurse, a protector, a creature under special protection. It's logical for a beetle that guards the harvest to receive the same name. In different regions of Russia, the cow was called differently: Solnishko, little sun, Bozha bukashka, ladybug. This is a Church Slavonic trace parallel to the Western European bird of the Virgin Mary. In some dialects, the bug is called a Mariashka, little bug. It's always something warm, homely, and protected by higher powers. There was also a sign. If a ladybug flies quickly from your hand, it means good weather. If it lingers and crawls, it means rain. Peasants observed insects as a barometer, and they weren't always wrong. Insect behavior does indeed change with changes in atmospheric pressure. Now about flight. The 22-spot ladybug is a good flyer. Its elytra are hard and protective. Hidden beneath them are membranous wings, folded in a special way. When the beetle opens its elytra and spreads its membranous wings, it can fly several kilometers without stopping. For a 3-millimeter-long creature, this is a colossal distance. Flight explains the speed of dispersal. The beetle doesn't crawl along the ground from region to region. It rises into the air, catches an updraft, and ends up wherever its nose smells powdery mildew. A new plot, a new garden, a new population. So the beetle has spread. And then begins a story that could become a textbook example of how a misdiagnosis is more costly than the disease itself. In Soviet agronomic literature, the 22-spotted ladybird appears in sections on pests. Not because someone conducted a study and proved the damage, but because the logic was, if the beetle is on a diseased plant, then the beetle is to blame. The observational method of uncontrolled experimentation. You see the effect. You call it the cause. The recommendations were appropriate. Collect by hand, treat with insecticides, and destroy. Gardeners followed the advice and killed the beetle. The powdery mildew didn't disappear. On the contrary, it progressed. But this fact didn't alarm anyone because powdery mildew was still treated separately with copper sulfate and colloidal sulfur and fungicides. The biological connection between the beetle and the fungus didn't exist in the public consciousness. Only in the 1980s did Soviet entomologists begin publishing papers explicitly identifying the fungus-eating ladybug as a mycetophagus or fungus-eating insect, and its presence on fungid plants as a sign of natural biocontrol, not an attack. But inertia was strong. Popular gardening publications long listed the beetle as unwanted guests. Some websites still list it there. This is what really happens when a ladybug works on a leaf. An adult beetle scrapes mycelium, the fungal threads, from the leaf surface with specialized mouthparts so it doesn't pierce the leaf or suck out the cell sap. It scrapes the surface. This leaves behind characteristic light stripes, eaten out areas of the plaque. The leaf looks a little tattered, but alive. Without the ladybug, it would be covered in a solid white felt, slowly suffocating beneath it. One adult beetle clears an area equivalent to several square centimeters of leaf surface per day. It's not a lot, but there are many beetles, and they work around the clock. Now let's talk about control, but not the kind you're thinking about. Powdery mildew is one of the most resilient garden pathogens. The fungus erici and its relatives emerged alongside flowering plants about 100 million years ago. Since then, they have survived glaciations, climate change, and the dinosaurs. Modern fungicides work, but the fungus has the unfortunate ability to develop resistance, especially with regular use of the same product. The chemical method is a race. You apply the treatment, the fungus adapts. You change the product, the fungus adapts again. After several years of intensive chemical treatment, your plot may develop a powdery mildew population that can no longer be controlled by conventional fungicides. The biological method works differently. The predator and prey exist in balance, not completely destroying each other, but maintaining a level at which neither side wins completely. This is biocontrol. Not zero fungus on the leaf, but at an acceptable level at which develops normally. The 22-spotted ladybird is one of the few species that nature has selected for this role. Moreover, it was selected millions of years ago, long before humans began growing cucumbers. Some studies showed that in plots where insecticides were not applied and where the ladybird population remained powdery, mildew outbreaks were less intense and shorter in duration. They didn't disappear, but they faded more quickly. This was precisely because the biological agent was already present in the system and responded automatically to the growing food supply. Frankly, this ratio amazed me. We spend money on fungicides, killing a beetle that does the same job for free, and then we wonder why powdery mildew returns every year. The answer is in the garden. Small, yellow, with 22 spots. But don't think this beetle's life is a carefree stroll through the leaves. It has enemies, and dealing with them is a whole other story. Its main defense is that same bitter hemolymph. When the ladybug is picked up or grabbed, it secretes an orange-yellow fluid from the joints of its legs. This is called reflex hemorrhage. It sounds scary, but it's not real blood. It's hemolymph with alkaloids that cause a sharp, burning sensation in the predator's mouth. A single encounter is enough for a predator to permanently associate the yellow and black coloration with this taste and never touch it again. This system works so well that other insects take advantage of it. This is called the beetle mimicry. Completely harmless species, some beetles, leaf beetles, and certain species of bugs have evolutionarily copied the yellow and black color scheme of ladybugs. They themselves are not bitter. They simply resemble those who are, and that's enough. But there are predators that are not deterred by hemolymph. Spiders hardly react to chemical defenses. Parasitic wasps lay their eggs directly into the ladybug's body. The wasp larva develops inside the living beetle, feeding on its internal organs. The beetle continues to move and feed, sometimes until the very end. There's another enemy you might not expect. Another ladybug. The Asian ladybug, Harmonia oxyritis, an aggressive species introduced to Europe and the European part of Russia as a biological agent against aphids. An experiment that got out of control. The Asian ladybird proved so competitive that it began displacing native species. It's larger, more aggressive, overwinters in groups and occupies shelter first. There's no room left for native species, including the 22-spotted ladybird. This is a case where solving one problem created another, and now they don't know what to do about it. The story of the Asian ladybird is a tale of good intentions and unforeseen consequences. It deserves a separate discussion because it clearly demonstrates how nature works when we interfere too confidently. Harmonia oxyritis is native to East Asia, China, Japan, Korea, as well as our Far East and southern Siberia. There, it's part of an established ecosystem where it has competitors, parasites, and predators that keep its population within limits. A balanced system built over millions of years. At the end of the 20th century, entomologists in Western Europe and North America were looking for a way to control aphids without chemicals. The Asian ladybird seemed like the perfect solution. A voracious, undemanding insect, it reproduces well in captivity and actively eats aphids. It was first bred and released en masse in greenhouses to protect crops and in fields to protect orchards. Everything went well for the first few years. The aphids declined, the ladybug reproduced, and the reports were positive. Then it became clear that in its new environment, the Asian ladybug had no serious enemies. The parasitic wasps that had kept it at bay in Asia were not found here. Local predators didn't know what to do with it, so the ladybug began to do what any species does when unchecked. It began to spread. By the 2000s, it was already ubiquitous in Western Europe. It arrived in Russia later, around the 2010s. First in the south, then it began to move north. Now it has been recorded in the Moscow region. The problem isn't just competition for space. The Asian ladybug eats more than just aphids. When the aphids are gone, it switches to the eggs and larvae of other insects, including other ladybugs. Native species are literally on the invader's menu. We released a predator to protect the plants, and it started eating those who had already protected them. Okay, we figured out what the 22-spotted ladybird is, where it came from, and what it fights. Now for the practical part. What can a gardener really do if they want this beetle to thrive in their garden rather than die from their own actions? First and foremost, don't use broad-spectrum insecticides unless absolutely necessary. This sounds obvious, but in practice, most people reach for the spray can at the first sign of powdery mildew. The problem is that insecticides don't distinguish between pest and ally. They kill them all. The ladybird that came to your cucumber specifically because it smelled powdery mildew there is destroyed along with the fungus. Biological control is nullified. The following spring, the fungus returns, the ladybird is gone, and the cycle repeats. If a fungicide is absolutely necessary, choose products based on potassium bicarbonate or biological fungicides based on Bacillus subtilis. They are effective against the fungus, but significantly less toxic to the beetles. Second, leave overwintering sites. The ladybird overwinters in litter, fallen leaves, and cracks in wooden structures. A thorough autumn cleanup of the garden, including complete burning of fallen leaves and treatment of all surfaces, deprives it of overwintering sites. A small corner of the garden with untouched litter and a few old boards is sufficient. Third, do not destroy the larvae. Grayish-yellow, warty larvae on leaves are not a threat. These are future beetles. They feed on the same fungus. Their presence means that the population is reproducing right on your site. Fourth, keep an eye out for the Asian ladybird. If you see ladybugs with a very variable pattern, from almost black to red with numerous spots of varying sizes, it's probably Harmonia axeridis. It doesn't need to be deliberately destroyed, but it's useful to be aware of its presence. Where it dominates, native species are more difficult to control. Did you know before this video that the ladybug can be an ally against fungus? Let me know in the comments. I'm genuinely curious. The yellow one with 22 spots is working on your cucumber leaves right now while you're watching this video. Almost no one knows about it. It's killed along with the pests. Its larvae are crushed, mistaken for a threat. Old reference book still listed as an unwanted guest, but it's simply doing its job. Millions of years before vegetable gardens, before fungicides, before reference books, it scraped the white coating off the leaf. Millimeter by square millimeter. Nature doesn't make beautiful gestures. It doesn't send out remarkable heroes. Sometimes the defense looks like a small yellow bug you want to brush off your sleeve. Next time you see one on your plant, just leave it alone. It's already working.